Hi. We're now moving into a section called Displaying and Describing Quantitative Data. Okay. The joke, avoid the top of the bell curve, everyone there is mean. That's just a funny stats joke because right in the middle of a bell-shaped curve is where you'll find the mean. So anyway, top of the bell curve is the mean. Haha. So we're displaying and describing quantitative data. This is going to take us 4 class lessons or 4 days of work to accomplish this. Today, we're going to look at stem plots and dots. Okay. So quantitative variables. In this section, we're going to learn how to display and describe quantitative variables. A quantitative variable is one that takes on numerical values for a measured or counted quantity. So remember, these are things that have units like feet, and it makes sense to average them out, okay? As opposed to categorical variables, which were labels. So in this section, we're really working on numbers that are measurements. And there's 2 types of quantitative variables right here. There's discrete. These are things that can only be counted by whole numbers, okay? Like how many brothers and sisters do you have? How many pairs of shoes do you own? How many people are in this room? Okay, things that can only be counted by whole numbers, versus continuous variables, which could be things like height if you were 6.2 inches tall, or weight if you were like 100.7 pounds. So things that can be a decimal. Okay, those are a continuous variable. So all quantitative variables can be broken up into those 2. There's 3 types of graphs we're going to use to display quantitative data, and that's really where we're going to start this lesson, is making some graphs. So there's dot plots, stem and leaf plots, and histograms. Okay, and we're going to start out with the first 2 today, dot plots and stem and leaf plots, and then tomorrow we'll take a look at histograms. So a dot plot, pretty straightforward. There's an example of one on this page. It just represents each observation by a dot. It's pretty straightforward. And then we make a horizontal axis with all the possible values. This only works for discrete quantitative variables, because if you had to list out decimals in there, the page would get too large, wouldn't be practical, okay? So this only works with whole numbers. The pictures below is of a dot plot from last year's AP Stats class. We had the students reach into a bucket filled with dice and grab a handful and pull them out. And then they would count how many they could grab. So, and then the kids walked up to the board and put a sticker on the board above how many dice they pulled. So, obviously, making a graph of the information gives us a really fast way to learn about the data, okay? Like if I just had the list of 30 students and the numbers of dice they pulled out, and I showed you that list, it'd be hard to tell much about that information, okay? You'd be looking at individual numbers. But here you can see right away that, hey, one kid pulled 39 dice. That kid must have a huge hand, right? You can see if you pulled less than 20 dice, only 5 kids did that, okay? You can also see that there's kind of some peaks in the data. It looks like, somewhere between 22 and 30 is probably like a typical amount of dice that you could pull out of the bucket, okay? You can see there's like a group or cluster of scores at the top here. So it must have been a group of kids that had maybe very large hands, okay? But we can tell a lot more about the data when we make a picture than we can if we just have a list of numbers. So that's the purpose of making a graph of anything, is to get a better picture of the values that are in that set of data, okay? Dot plot pros at the bottom here. They're fast and easy to make and easy to read. They require no calculations. You just have to draw it out. Dot plot cons over here. They only work for whole numbers. You need a large number line if the data is spread out. Because notice I had to write in like every number on the line here, even numbers where there weren't a dot. So if you had numbers starting around in the single digits going all the way up to 100, you would need a line that has 100 spots on it. So with big sets of data, they're not super practical. Okay, but that's a dot plot. Another type of graph we can use with quantitative data is called a stem and leaf plot. And I'm sure you are familiar with these. You've probably made them before. Okay, there's an example on the right. Remember that these are the stems over here. Okay, and that's typically the first digit of the number that we're trying to graph. And then these over here are called the leaves. And those are the second digit of the number I'm trying to graph. Okay. When you make one of these, you always want to make a key, which explains how the stem and leaf is set up. So this means that a stem of 2 and a leaf of 5 means 25. So when you make a stem and leaf plot, you always want to provide a key like that, okay? And then, of course, like this number right here, this number 9, is actually the number 39, right? Because I take the stem from the first column and put it with that 9. Another thing you notice is that the leaves go in order when I write them down. So like I have 0, 2, 3, 4, 7, 7, 7, 8, 9. So that is, you want those leaves to be in order. Okay. Now, just to give you a quick example of how you make one of these, we're going to create a stem and leaf plot of data below from a class set of data that was collected last year and the number of states visited by each student in an AP Stats class. So one of my classes last year. So to make a stem and leaf plot, the first thing you do is draw a vertical line and then a horizontal line across the top, kind of like a T. And down the vertical line, we're going to list all the stems. So there are some single digits, obviously, and those have a stem of 0. There are some teens right here. Those all have a stem of 1. The first digit's 1. We have some 20s, so I need a 2. We have a 35, I need a 3. We have a 45, I need a 4. And I have a 50, so I need a 5. Okay? And now I basically just put the leaves next to their stem. Now, I put this data in order for you because it makes it a little easier to do. So it starts at 3, 5, 5, 6, 6. If you had just a raw set of data that wasn't in order, you may want to put it in order first. Because remember, the leaves have to be in order. So then we just start writing down the leaves. So for 0, the leaves would be 3, 5, 5, 6, 6, 7, 7, 7, 8, 9. I need a leaf for every number that's in the set of data. So even the ones that repeat, they get repeated. For the teens, there's 3 10s, so that would be 3 zeros. And then 4 1s, because I have 4 11s. We have a 12, a 13, a 13, a 13, a 15, a 15, a 17, and a 19. Okay. Then I have 20s. So we have a 20, a 21, a 23, and a 26. For the 30s, I only have a 35. For the 40s, I only have a 45. And for the 50s, I only have 50. Okay. Then I would also do a key at the top here. So I might do something like 1 line 3 equals 13. That way someone can read the stem and leaf plot. Now we can see, after making this graph, we have a better idea about how this data is distributed. Notice that most kids in my class had seen, between 10 and 20 states. Okay, that was the largest group. You can also see that very few kids had seen more than 30. In fact, only one had seen in the 30s, 35, and one person had a 50. So you can get a pretty good picture of the data by making a stem and leaf plot. I can see things here that I couldn't see in the raw data themselves. Okay. So that's a regular stem and leaf plot. There's another kind of stem and leaf plot called a split stem and leaf plot. And here, each stem is split into two parts. The first part is for the leaves from 0 to 4, and the second part is for leaves from 5 to 9. So if you look at the picture on the right, you can see there's 2 0 stems, 2 1s, 2 2s, 2 3s, etc. Okay? And then we only put the values 0 to 4 on the first stem, and we do 5 to 9 on the second. So we're going to make one of these for our states visited data below. Okay, so I'm going to make the vertical line again and a horizontal line, but this time I have to do 2 stems for each. Where I had 1 before, I'm going to split them into 2. So now just keep in mind it's 0 to 4 in the first one, 5 to 9 in the second. Okay, so for the first one, we'll just get a 3, because that's the only value up here that's 0 to 4. And then 5 through 9 would be 5, 5, 6, 6, 7, 7, 7, 8, 9. And then the first one, this one, would be anything below 14. So it'd be all of these. So it'd be a 10, 11, 11, 11, 11, 12, 13, 13, 13. And then on the second one, the second stem with a 1, I would do 15, 15, 17, 19. And then for the 20s, there's 3 below, so they'd go on the first one, 20, 21, 23. And there's 1 above, so that would be 26. Remember, we're doing 0 to 4, and 5 to 9. For 30s, I have a 35, which would be in the second one. 45 would be the second one, and 50 would be the first one. Okay. Again, I would do a key, so maybe 1, 3 equals 13. What a split stem plot gives us is more details. Okay, because it splits the data up into smaller groups. So now, remember when we looked at the first graph, we said, wow, it looked like most people had seen states in the 20s, right? Like between like 10 and 20. But now if you look at it, the biggest group is really from 0 to 9. Or, 5 to 9, this group. And then the 10 to 14 also was a pretty big group. So it looks more like, instead of from 10 to 20, it was from 5 to 14 was the biggest group, okay, or the typical group. And then we see also get a little more idea of the spread here, that this 35, 45, and 50, those were really far away from the other. Those kids had seen much more states than the other kids. So a split stem and leaf plot gives us just a little more detail, okay, which is good. Sometimes we need more detail. There's one more stem and leaf plot, and this is called a back-to-back stem and leaf plot. And these are used to compare two groups across the same variable. Okay, stems go down the middle, and then we put the leaves on each side of the stems. Be careful when you're reading these, because the numbers get bigger the further you get from the middle. Okay, so one thing last year I asked the kids if they were Coke or Pepsi drinkers, and then I kept track of the states visited for each one. So we're going to compare and see, if you drink more Coke or Pepsi, do you visit more states or not? Because it's often in statistics fun to see how two variables interrelate with one another. Okay, so again, what we're going to do here is, instead of one vertical line for these, we're going to do two. And then we do a horizontal line across the top. The stems go down the middle, and we'll do just the regular stem plot. We could do a split back-to-back stem and leaf plot too if we wanted to. One side we'd label Coke, I'll put them over here, and one side we'd label Pepsi. So let's do the Coke side first. We would do 5, 5, 6, 7, 7, 7, 9, and that's it for the first one. And then the next one would be 10, which remember you do the second number, so is the leaf. So for 10 I put a 0 out here. 0, 0, 1, 1, 2, 3, 5, 5. And remember, we're only doing the Coke side. Then 7 and a 9. And then I need to do these 4. So I'd have a 20, 21, 23, and a 45. So when you're reading these back-to-back stem and leaf plots, just be careful. Remember, like this number right here is actually 23. We do the stem first, okay? Sometimes kids get confused and think that 3 stands for 32, but remember the stem comes first. Then for Pepsi, I would put them on the other side. So for the first, it would be 3, 6, 8. Then for the next stem would be 10, 11, 11, 13, 13. Then for the 20s, it'd be 26, 35, and 50. Okay, so now I can compare the two together. One thing obviously that sticks out to me is that there were a lot more Coke drinkers in my class last year than Pepsi drinkers. But you can see even inside each group, each soda preference, the teens were the highest proportion of states visited, right? And you can see, above that area, they both have just very few. Okay, so that's not a super interesting comparison to do like soda preference and states visited because they probably have nothing in common. It's more interesting to compare variables that do have something in common, which we will do later on in the course. So that's what you need to know for stem and leaf plots. I want to show you one more quick example here. Notice this data has decimals in it, okay? We can make stem and leaf plots for these. The first numbers would be the stems, and the second, or the 10th place, would be the leaves. So I'd make my little chart. Looks like I have some numbers that have 0 in front of them, so I'd put 0 here. Then I have some numbers with 1s. I don't have any 2-point somethings, but I still include it in the stems. Then I have 3s, 4s, and 5s. And then I would just fill in the leaves, which would be the 10th place of these decimals. And there's no 2-point anythings. Then I have a 3.1, 3.3, 3.4, 3.6, 4.1, 4.3, 4.4, 5.1, 5.2. And on this, obviously you can see the need for a key on this one, because without the key you would think that this 2 represented a 12, but that 2 actually represents 1.2. So I definitely need to have a key there. Stem plot pros, they are easy to make. They're pretty fast. Gives you a quick picture of the data. Okay. Cons, they do not work well if you have over 2 digits in your values. Okay. When you have over 2 digits, they get super big, super messy, and you lose the efficiency. So a stem and leaf plot is best when you have just a small set of numbers that are maybe 2 digits long, like quiz scores on a quiz, or IQ scores maybe would work well. Things that have just 2 digits, maybe 3, that we can and we need just a quick graph. For bigger sets of data and bigger numbers, and for bigger decimals, we have better ways to do that, and we'll learn those later on. Okay, so good luck on dot plot and stem and leaf homework.